Hello friends, today I am going to deliver lecture on the topic of equilibrium in a strategic form of extensive game with perfect information. So in this topic we need to understand first what is extensive game with perfect information. So extensive game with perfect information means a game in which we have information of order. Order means in which order the player will take action. If any game, in any game we have information in what order the player will take action, then we can say that this game is a extensive game with perfect information. Okay, now we will try to find out the equilibrium we will try to find out the equilibrium in extensive game with perfect information, and we will consider this extensive game as in the form of a strategic game. And we already have seen so many strategic games in which we try to find out the equilibrium using the best response function, and we will apply the same method in the extensive game with perfect information. Okay, so to consider the extensive game with perfect information, I have taken an example of entry game. This entry game is a game of two players in which the players are challenger and another one is the incumbent. So in this game we have a market. Okay, we have a market. In this market we have a player incumbent and he is a monopolist. He is a monopolist means he is the only player in the market right now. Okay. Now the incumbent is facing a problem. He's facing a possibility that the another player, that is the challenger, may enter into the market. Definitely, if challenger enter into the market, the market share of the incumbent will decrease and he will get less profit. Right. So incumbent never want the challenger to enter into the market. So this is the entry game. So who will take the action first here in this game? The challenger will take the action first, because it is up to the challenger whether to enter into the market or stay out from the market. If challenger enters into the market, then who will react? Incumbent will react as per the action of challenger. Right. So here challenger is the first player, because the action of challenger will decide what the incumbent will perform, what action the incumbent will take. Right. So the action of incumbent is dependent on the action of challenger here. Okay, so that is why the challenger here is the first player. So in this game we have the information of order, right? The challenger is the player who will take the action first, and incumbent is the player who will take the action next after the challenger. Okay, so this is the point. This root node is a point of empty history, means nobody has taken any decision yet. Okay, so this is the point of empty history. Okay, now at this point the challenger is the player who will take the action, who will act. Now the challenger is having two actions available, one is the in, another one is the out. Two actions are available to the challenger. Either he can enter into the market or he will stay out from the market. If he enters into the market, then incumbent will react in response of that action. So this is the point of history of in, because we have reached this node after taking the action of in, right? So this is the point of history in. Okay, at this point the incumbent is the player who will take the action, right? So at this point two actions are available to the incumbent, one is the accommodate, another one is the fight. Okay, so if incumbent take the action of accommodate, means he is accommodating the challenger in the market, definitely the market share of incumbent will decrease and his payoff will decrease, right? And the challenger will get more payoff. In this case the challenger's payoff is 2 and the challenger of incumbent is 1. Okay, now what would happen if incumbent takes the action of fight? So if he do fight with the challenger, then both will be involved in the fighting and nobody will do business. So both will get the payoff of 0 in this case, 0 and 0. Okay, now what would happen if challenger choose the action of out? Means he will stay out from the market. If he will stay out from the market, then definitely this will be the good condition for the incumbent, right? And he will get more payoff, and definitely challenger is not in the market, therefore he will get less payoff. So here in this case the payoff of challenger is 1 and the payoff of the incumbent is 2. So this is the entry game. Okay, now we will try to find out the equilibrium of this game. Okay, and to solve this problem we will use the same strategy which we used in the strategic games. We know in the strategic games we use the payoff matrix and then we calculate the best response function to find out the equilibrium. Okay, so for this extensive game also we will construct a payoff matrix and then we will solve this payoff matrix, and then we will see whether the equilibrium is correct or not. Okay, so this is our challengers game, entry game, and we will try to find out the payoff matrix first. So this is the payoff matrix for the two players. The player are challenger. The first player is challenger and the next one is incumbent. Now what actions are available to the challenger? The in and out. And what actions are available to the incumbent? The accommodate and fight. Okay, now what would happen if challenger takes in and incumbent takes accommodate? So in and A, if we traverse this tree and we will reach to this 2, 1. So this is the payoff for the challenger and this is the payoff for the incumbent. Now in fight, so this the challenger is taking in and the incumbent is taking fight, so both will get here 0, 0. So 0, 0. Now challenger taking out. Okay, so here in this case the challenger is taking out and the incumbent is taking accommodate, but we don't have any sub game in this game tree like this, so we will extend this. Okay, so this is the point where the incumbent will take the action. Either he will choose accommodate or fight. Okay, now if challenger takes the action of accommodate, if challenger is taking the out and incumbent takes accommodate, tell me, is there any change in the payoff values? No. Why? Because challenger is not in the market. Whether the incumbent takes the action of accommodate or the fight, it will never affect the payoff values. Payoff values will remain same, right? Whether he choose accommodate or fight, the payoff value will remain same. So in both the cases the payoff will be same, the 1, 2, because challenger is not in the market. Whether the incumbent takes the action of accommodate or the fight, the payoff will remain same. So in both the cases we will get the same payoff. Okay, so this is the payoff matrix. Now we will try to solve this payoff matrix to find out the Nash equilibrium. Okay, so this is the same payoff matrix and we will try to find out the Nash equilibrium. We know for to find the Nash equilibrium we will try to find out the best response function for both the players. So best response function for challenger when he is taking in, so best response function for the challenger when he is considering that the incumbent is taking accommodate. So which one, what is the output here? So best response function. So here I am playing for which sub game? In and accommodate. Okay, in and accommodate. I am considering this pair as a equilibrium. So in A is the equilibrium. Okay, if this is equilibrium, what condition need to be satisfied? So BCA should be what? So the best response function, best action for the challenger when the incumbent is taking accommodate. So we will check here. If we take in, he will get the payoff of 2, and if we take out, he will get the payoff of 1. So which one is best? The in is best, so we will get in. Okay, now as per this equilibrium, the in A, what other condition need to be satisfied? So V incumbent, and he is considering what? In should be the action of the challenger. So what we will get? So the incumbent is considering that the challenger is taking in. Okay, so which one is best? Here is getting 1 and here is getting 0. Which one is best? 1 comma 0. Accommodate is the best, so he will get accommodate, right? So as per these two best response function, we can say that this is a equilibrium. In comma accommodate is the equilibrium, because we know if b1a is b and b2 b is a, then we can say that a comma b is a equilibrium. So these two conditions are satisfied here, and we can say that in comma a is the equilibrium. Okay, now we will try to now we will try to check the other combinations for the equilibrium. What can be the other combinations? The in comma fight. Okay, so again we will calculate the best response function for challenger when he is considering that the other player is doing fight. Okay, so tell me, if the incumbent is doing fight, which action is best for the challenger? So here if he choose in, he will get 0. If he choose out, he will get 1. So out here is the best, right? Now as per this equilibrium, what can be the other condition? The best response function for incumbent when he is considering that the another player is taking in. Okay, so here this player challenger is taking in, and we need to find out the best action for the incumbent. So if he take acquiesce, he will get 1, and if he choose fight, he will get 0. So accommodate is the best, right? Accommodate is the best. So here as per these conditions, this condition is these two conditions are not satisfying, because by passing f we are not getting in, when by passing in we are not getting f. So both the conditions are not satisfied, and we can say that this is not a equilibrium. Now we need to check for other combination like out comma fight. Okay, now if we check for this combination, what condition need to be satisfied? So b challenger, best response function for challenger when he is considering that the other player is taking fight, should be out, right? Should be out. And what condition need to be satisfied for the incumbent? So the best response function for incumbent when when the other player is taking action of out, should be what? The fight. Okay, so we check it, the BCF is equal to out or not. So the other player is taking fight, so which one is best for the challenger, 0 or the 1? The 1 is best, means out is the best. So this condition is satisfying here, right? Now we check for this condition, v1 0 out should be equal to f. So this one, the challenger is taking out, and which one is best for the incumbent? If we take incumbent takes accommodate, he will get 2, and if incumbent take fight, he will get 2. Both are same. So here we are getting what? We are getting both fight and accommodate as the output. So here this should be the fight, right? So this condition is also satisfying, because fight is in the output of the best response function. So these two conditions are satisfying, and we can say that out comma fight is the equilibrium of this game. Now we will check for the last combination, which is out comma accommodate. Okay, so as per the Nash equilibrium condition, so v challenger accommodate should be equal to out, and bi best response function for incumbent when the other player is taking out should be accommodate, right? So we need to check these two conditions. So in this, the the best response function of challenger when the other player is taking accommodate. So here is getting 2 and here is getting 1. So which one is best? In is the best, but here we are getting out. So this is not a Nash. This condition not satisfying, and we don't need to check this condition because already this condition is failed. So this is also not a Nash equilibrium. So only in this game we have two Nash equilibrium. One is the in accommodate, another one is out comma fight. But in this game one Nash equilibrium is reasonable and another one is non-reasonable. So which one is reasonable and which one is not reasonable? So in comma A is reasonable and out comma fight is not reasonable. I explain you why. If you look at this game tree, and look at the equilibrium, what equilibrium we have got? In comma accommodate and out comma fight. Okay, now if in comma A is the equilibrium, means what? The challenger enters into the market and the best response for the incumbent is accommodate. Let's check for this subgame. So in this subgame, if incumbent takes action of A, he will get the payoff of 1. If incumbent takes the action of fight, he will get the action of 0. So this action of accommodate is fit for this subgame. For this subgame, the action of accommodate is valid, right? Now if he is accommodating, the incumbent is accommodating. Now which one is best for the challenger? So if challenger takes in, and we know the output of this subgame. The output of subgame is what? The incumbent will take accommodate and he will get 2. And what if challenger takes out? He will get what? 1. In both the cases, whether the incumbent takes accommodate or fight, in both the cases he will get what? 1. So if I compare 2 with 1, which one is best? The 2 is best, right? 2 is greater. So means if challenger takes in, the challenger will get 2, and if challenger take out, he will get 1. So in is best. So means what? This is valid for the whole game tree. This equilibrium is valid for the whole game tree. Now we will check for out comma fight. Okay. Now we will check for the out comma fight. Out comma fight means the challenger is taking the action of out and the incumbent is taking the action of fight. Okay. So this should be valid for the whole game tree. Means this should be valid for all the sub games that are present in a game tree. Okay. Now if we check for this game, if we check for this sub game for outcome of fight, means what? If player is having, the player here is having two actions available, accommodate and fight, and we know if incumbent takes the action of the action of accommodate, he will get the payoff of 1, and incumbent if takes the action of fight, he will get the payoff of 0. So which one is best? Accommodate is the best, right? But as per this equilibrium, he is saying that the incumbent strategy will be of fight. So this is not benefiting the incumbent. This is not benefiting the incumbent in this game, in this subgame. In this subgame, this is the action of fight is not valid for the incumbent. So this is unreasonable. This is what? This is unreasonable equilibrium. And this one is reasonable equilibrium. So means the conclusion here is, if we if we solve the extensive game with perfect information, like we solve the strategic games, then we can find out some equilibrium reasonable and some equilibrium can be unreasonable. So the conclusion here is we cannot solve a extension game with perfect information like we solve the strategic games. So we need some other, we need to try some other techniques by which we can find out the equilibrium that are reasonable only. Okay, so this is the end of the lecture. Thank you.